Good day, everyone, and welcome to the UBS Energy Transition Call hosted by John Wyndham. My name is Thomas, and I'm your event manager for today. During the presentation, your lines will remain on listen only. If you require assistance at any time, please press star zero on your telephone, and the coordinator will be happy to assist you. I would like to advise all parties this conference is being recorded. And now I would like to hand over to John. Please proceed.
Perfect. Thanks, Thomas, and welcome everybody to the latest installment of the UBS Energy Transition Call Series. So in this call series, we try to connect UBS institutional clients with energy experts and innovative companies that are in some way enabling or driving the energy transition. So as usual, this is your host, John Wyndham. I head up Alternative Energy and Environmental Services Equity Research here at UBS. And today, we're going to be talking lithium battery recycling with RecycLiCo Battery Materials. It's actually American Manganese Incorporated, listed AMY, but it's doing business as RecycLiCo Battery. They are a cathode materials company based in British Columbia, Canada, focused on upcycling lithium-ion battery waste into high-value battery cathode materials using a closed-loop patented process. So on this call today, we're going to discuss RecycLiCo battery materials strategy and current trends, challenges and opportunities for the lithium battery recycling industry. Very happy to have with us today Zarko Megalgia, which Zarko, if I mess that up, all apologies. I'm a bit of a mumble mouth in general, so that's on me. He is the CTO and director of American Manganese. Before I turn it over to Zarko, just a few logistical items. First, there are slides to accompany today's discussion. They were distributed via email to pre-registered UBS clients about 5 minutes ago. If you need a copy of that, do feel free to email me. I'm sure if you found your way to this call, you have my email address. It's john.wyndham, WINDHAM, @ubs.com. Again, john.wyndham, WINDHAM, @ubs.com. And just a note, if you registered with a Gmail address or Yahoo, I'm not able to send slides to you. There's a firewall essentially for UBS Equity Research. But if you have a work email and you send me an email, I will make sure the slides get to you. But most of you should have gotten them in the last 5 minutes. All right, the format of today's call will be a presentation by Zarko, followed by Q&A. Thomas, the operator, will provide instructions on logging any questions after the presentation. And always, if you prefer, you can email me questions directly, and I will ask them anonymously for you as time permits. And now, lastly, a disclosure: as UBS research analysts, we are required to provide certain disclosures. The short of it is, this call is not a recommendation. This call, in and of itself, is not a recommendation by UBS to transact in any security. A full list of disclosures is available on ubs.com/disclosures. All right, Zarko, thank you so much for being here today. Let's get into the fun stuff. Lithium-ion battery recycling, not something that entered my life a lot before 2 years ago, and now it's between RecycliCal going public and just I think people looking at the sustainability of this ramp and both batteries for EVs as well as batteries for the grid, really thinking through what the final solutions and just the TAM seems to be very large, and the opportunity set for creating business models around creating sustainable solutions for lithium-ion batteries. So really appreciate you being here today. And with that, I will turn the floor over to you.
Yeah, thank you, John. And you're right. This really hits on a lot of hot topics right now, related to EVs, sustainability, metals, looking at the current supply chain as well. So we're going to talk about all that and how recycling really fits in. So like you said, everybody should have some slides with them. And I'll be going over, I'll try to reference as much as I can for those just listening. But yeah, we are RecycLiCo Battery Materials, are doing business as RecycLiCo Battery Materials, currently transitioning from our American Manganese Inc. name. And we are publicly listed, as John had mentioned. So as we get to the first or slide number 2, some quick background on us is we're based here in Greater Vancouver, and working on the lithium-ion battery recycling and upcycling. So we've been doing this since 2016. We have multiple publications and patents involved with the recycling work. So we have patents in the U.S., Korea, Japan, Canada, China, and India. And really, with this technology play, is where our business model fits in best is the technology, is the licensing and joint development of our technology. And we have done a really methodical approach in building up this technology and making sure we de-risk it as we scale and ensuring efficient operation at these larger scales. So we've gone from initial theoretical work, some bench scale testing, and now we have a lot of updates on our demonstration plant work that's here in the Greater Vancouver area. If we go to the next slide, number 3, just a quick overview and an understanding of the lithium-ion battery industry and its components and costs. The lithium-ion battery being made up of cathode, anode, separator, and electrolyte, but really it's the cathode that we're focusing on, because that's where you have your composition of lithium, nickel, manganese, and cobalt. And I'm sure you've read about these metals in the news. A lot of supply chain restrictions, a lot of increase in prices as well over the last few years. So there's a big focus on recovering these materials, whether that's through primary or recycling, because when we look at the estimated material cost, that cathode component can make up over 50%, or just about 50% of all the other material, of all the material costs put together that go inside a lithium-ion battery, and even going up more as these prices start to increase. And then when we go over to looking at slide number 4, where we have the traditional supply chain, as I like to say, it's complex and it's linear. We mine lithium in South America. We get cobalt from Africa. We get nickel from Asia Pacific region, and all of this is really mined, processed, shipped to specific refining locations, and really all concentrated in mostly China, where these materials are converted into what we call metal salts, like nickel sulfate, cobalt sulfate, and then these materials are further refined into a higher value product that's called a precursor cathode active material, or PCAM, and as well as like lithium hydroxide. And it's from these materials that you would then produce, different cathode active materials that would go further into the battery manufacturing process, and then finally into electric vehicles. So many steps, a lot of transportation of these materials, and when we just think from the sustainability side of things and the mining of these materials, I think the local populations in each of these individual areas all have their concerns with the mining practices. So we really have to reach a point of recycled material and batteries to reduce our reliance on mining as well. But yes, I'm not. It's a big environmental impact, and we're not going to get rid of mining tomorrow. But recycling is a complement to that. And further on that, in slide 5, when I talk about China's dominance in this processing and refining space, they've really developed a mature industry. And then when we look at throughout the whole supply chain, from the chemical processing and taking these mined materials into the production of those individual cathodes and anodes, and as well as the lithium-ion battery manufacturing, China is well over 50% of all the world's capacity. And then as we see, there's going to be an exponential growth in electric vehicles, and with this, we've become extremely reliant on China, and there is a focus now in North America and Europe in growing gigafactory capacity. So that's the actual battery manufacturing, as well as kind of the midstream components, the processing and refining of these chemical materials. And as you'd see in slide 6, there's the different initiatives from European and North American gigafactories that are being announced. According to Benchmark Minerals, there's over 1,400 gigawatt hours of lithium-ion battery capacity planned for by 2031, and every watt hour in this, that's built is eventually going to need to be recycled, whether that is directly from the manufacturing process or later at the end of life of that battery. And to many people's surprise, there's two streams of material or feedstock that is a good potential for recycling. One is near term, and one is more of a longer vision. And I talk about the first being the off-spec battery production scrap as the near-term recycling opportunity. This is essentially when the lithium-ion battery is being made. There is a certain quality that needs to be achieved, and that cannot be perfect every time. And then this material is disposed of as off-spec, not good enough, and it's just more so treated as a waste. But it still has all of your valuable lithium, nickel, manganese, and cobalt on there that you can recover. And essentially, what you're seeing on slide 7 in that left picture is a mixture of those components coated onto an aluminum foil, and this is where we focus our process on extracting that material into new high value materials. The second potential feedstock is the black mass material, and this really comes from the end of life component of a lithium ion battery. So this is where now the EV has reached its end of life, whether that's 10, 12, 15 years later, and those cells and modules are shredded and separated, and essentially what you get is, as the name indicates, a black mass. And this, within this black mass, you still have your valuable lithium, nickel, manganese, and cobalt in there, which can be chemically extracted by our process and refined into really high value materials. And as we go into, when we talk about scrap and focusing on scrap first, we see that the off-spec production scrap, from some examples found online, is that these numbers can reach 30 to 40% on average. We assume more of a steady state of a 10% loss in battery production scrap, but even from a battery manufacturer's perspective, losing 30 to 40%, even 10%, is a significant loss when you're trying to get out as many batteries as possible right now, because the demand for electric vehicles is just enormous. So this is where, being able to recoup this material, not only recoup the material, but also, achieve a truly green and sustainable supply chain is another initiative for these battery manufacturers to start looking at, what can we do with this scrap instead of, selling it as a waste material. And then to put that in reference and how much just the scrap material can be, on slide 9, if we took that from the earlier slide where we said the North American and European market expect to have about 1,400 gigawatt hours of battery production. If we just took 10% of that as scrap material, and this is on a per year basis, if we just took 10% of that, the equivalent amount of lithium, nickel, cobalt, and manganese found in that just 10% scrap would be more than the mine production in individual countries that was mined in 2020. So, for instance, the amount of nickel from 10% scrap in this North American European market would be 105,000 tons, it's estimated by our calculations, versus the 49,000 tons that was mined in Cuba in all of 2020. So, putting this in perspective, this is the directly on site. This is material that with an efficient process can be recovered and be introduced back into the supply chain. And I guess you'll see kind of where I'm going with this when we get into talking about RecycLiCo and how our business model aims to achieve and maximize this material. But first, on slide 10, I'll also talk about the other stream. So what happens when the other 90, so we have 10% that goes into scrap. What happens to the other 90% when it actually goes into an electric vehicle and it goes through the rest of goes through its whole life process and reaches its end of life after many years of driving or used as energy storage. And then those batteries, as I had mentioned, would go through these stages of collection, size reduction, so shredding these materials back down into black mass. And all of that can be, the nuance of the word recycling, all of that can really be defined as recycling. You'll see a lot, sometimes the collection services are recycling the batteries, the mechanical shredding services are recycling the batteries, but then there's also the chemical treatment that's referred to as recycling. And there's the discrepancy in terms of how that is defined, or it's not an apples to apples comparison when we're talking about collecting battery packs versus chemically treating black mass and producing really high value and usable products. So I will tell you to keep that in mind as we go through this and you hear more news on recycling. There is that disconnect in terms of how those things are defined and a different level of know-how when it comes to these different processing steps. But when it comes to the chemical treatment or hydrometallurgical recycling of these batteries, what we see in a lot of these competing technologies is just the individual breakdown of the materials that's in the black mass to go back and almost into this intermediate product, as you've seen in the traditional supply chain, that produces those cobalt sulfate and nickel sulfate and still need to be further refined. Whereas our RecycLiCo process, we call it recycling and upcycling. So it's taking this material and upcycling it, so producing a higher value product, which would be that final or near final product, which is the precursor, the PCAM, or the lithium hydroxide. So those are the two streams that we produce as a product that we go back into new lithium-ion battery manufacturing. And this is more of an another in-depth look when we see page 11 and how our process compares to some of these competing, or what I see, very conventional routes of recycling. Looking at the competing routes, they have this chemical leaching process, and you're talking very large facilities with high capital costs, high energy costs. Again, as I mentioned, it's the production of an intermediate product with very low lithium recovery, and there's just multiple steps that increase the complexity and practicality of recovering these materials, especially if you're going to break these materials down into their individual streams, only to recombine them again to make the higher value precursor materials. And then with that, comes more processing steps, more chemical consumption. With that comes an extensive liquid and waste production, and just large consumption of chemicals. Whereas our process, we have our patented RecycLiCo leach, and from that, once we pull all the metals into solution, we adjust and are able to what we call co-precipitate directly into that precursor cathode active material, so that PCAM, and as well as have over 99 or even up to 100% extraction of even lithium, nickel, manganese, and cobalt that's within these battery materials or battery waste, and as well as through a proprietary process of our lithium recovery, we also regenerate the process chemicals. So what we find is that there's a large benefit to cost using less chemicals, as well as environmental impact, which we've recently shown in our LCA, our life cycle assessment report, that was done by an independent party called Minviro. So what they did within this life cycle assessment is go through our model data, where we've submitted over 1,500 streams of inputs and outputs of our process flow sheet, and looked at every fine detail, every output, every input, what comes out, where are the emissions, and we're looking at scope 1, scope 2, and scope 3 emissions. And we compared our process to what we see is these competing hydrometallurgical battery recycling processes, and as well as primary extraction. Obviously, we know that in primary extraction, we've definitely more efficient to recycle, versus the mining, processing, shipping, and throughout the world and multiple times around the world. But when we compare to the competing hydrometallurgical battery recycling, we see 166% reduction in those CO2 equivalent emissions. This is known as the global warming potential. Now, putting that in context, like what does that mean? 166% reduction. From our calculations, the best way we can express this is that if we were to recycle 1 gigawatt hour of battery material with a competing hydrometallurgical battery recycling process, that variance from between ours and the competing would be an additional 17,000 tons of CO2 emissions, or equivalent to 3,700 vehicles per year on average. Now, put that in context to just the North American and European market, where we have projections of battery production to go up to 1,400 gigawatt hours. Now, like I said, every gigawatt hour, every watt hour is going to need to be recycled, and we need to be conscious of what methods we're using, because saving on CO2 emissions throughout the life of this vehicle, we're going to lose it once we start, if we're recycling with inefficient methods, high heat, high, waste production. So this is a very important topic to show, and this has been, third-party validated, as well as gone through the ISO compliance. So now I'm on slide 13. It's really getting into more details of what we're all about, talking about our all-in-one circular solution, so going waste to cathode. So this is that final product. And when I talk about recycling, that's up to 100% leach extraction of the lithium, nickel, manganese, and cobalt, and as well to emphasize on that upcycling, so the synthesis of high-value, specifically engineered cathode precursors and lithium chemicals. And you'll see in one image with the cathode precursors, some of the really finer details when it comes into what makes a good cathode precursor material. They're just from a microscopic image, you'll know from the spherical shape of the balls, the density, the distribution of these particles, the size of these particles, and then when you look at physical characteristics such as tap density, current efficiencies, these are very important factors that need to be considered to be usable in a lithium-ion battery. So these are really fine details that our team has shown to achieve. And summarizing that earlier supply chain we saw, really reducing those steps. And on slide 14, we show what an integrated battery recycling technology can look like, and why integrate this battery recycling technology. Because as I mentioned, our business model is the licensing and joint development. So for lithium-ion battery manufacturers, electric vehicle OEMs, chemical companies that are within the supply chain, this is an opportunity for them to take, advanced recycling technologies and incorporate it within their supply chain, co-locate the plant or directly on-site or near-site to take waste materials, recover them into high-value materials, and then have that go back through into battery production. And this way we can keep these valuable materials, the lithium, nickel, manganese, and cobalt, really within the same footprint as a gigafactory. Many benefits to that. You're closing the loop. And when we talk about closing the loop, there's different ways you can close the loop. You can have a small loop or you can have a very large loop. Eventually the material will make its way around. This is a very small loop, and it's directly situated or nearby where these materials are. As well, you reduce your reliance on mined materials. We see that there's a lot of growing pain in bringing new mines online. That's been a challenge. Many different countries, permitting issues, and we rely on that supply. So for a battery manufacturer, an electric vehicle company that needs more lithium, that needs more nickel, can look to their own supplies, recover these materials, not send them to an independent recycling company that will then process it and sell it into the market. This is a way where we see long-term companies are going to want a more integrated approach. And we're seeing this now where never before have I seen a vehicle company interested in mining, but the interest is there. And, I think recycling naturally fits in. Integrated also lowers the environmental impact. If we think about transportation of these materials, if these materials don't have to go very far and there's processing on site or nearby, and these materials can be circulated back without having to go from North America to Asia and then into Europe to make batteries and back, these are also some major benefits, and you're recovering the maximum value, right? If you own your material and you're not selling it for some lower value as a waste to an independent recycler, you recover maximum value here from these materials. And finally, on slide 15, just a quick note on our road to commercialization and understanding kind of these steps. So, like I mentioned, since 2016, we've been going through pilot plants and just continuous R&D work, improving. There's just so many fine details. Working through all of those really diligently, understanding each step and making sure that it's practical. That it scales and it's practical. And now we're at this demonstration plant scale where we've moved into 500 kilogram per day input capacity, and that's of the input materials I discussed earlier. And with this demonstration plant, as it is in the name, we demonstrate what is this scaled up operating conditions, those real world operating conditions. And this is something really important to potential partners, collaborators who are looking at how our process scales, how our process works. They want to see it at, we've demonstrated what we can do on bench scale and pilot, and we've sent materials to different third parties as well. But I think part of any due diligence process as well is that, and before licensing or joint developing with the technology is really want to see how it pans out on these large scales. And that's where we look to qualify with these potential strategic partners, the output materials, see how the quality of it at this continuous operating scale and very large operating conditions, and then and as well as just validate that those steps. So we do have a lot of visitors to our demonstration plant, seeing how things are working, and then as well from that. We would license and joint develop the technology. So we're looking at, whether it's multiple locations around the world with different battery manufacturers, EV manufacturers, chemical companies. This is where, we're going through these steps. And sometimes we get that comment. We put out pictures, videos. They see our equipment and they say, "Oh, looks like there's actually work being done." There's a lot of material being processed through. And right now, we're even processing cathode scrap material, like I showed you in the pictures on the slides there. So there's continuous work being done when we have the demonstration plant running. We're running day and night. We're analyzing as we go as well. Just working through all those finer details and trying to make sure that the parameters we achieved with that up to 100% extraction rates and purities of material, that we're also achieving that at this scale. So making sure all that is lined up is a critical step and one I think industry understands. And then that's the end there on slide 16. You'll see more pictures of our demonstration plant. If you're in the area, you always feel free to contact me. we're always happy to have visitors. We put out regular updates on on our progress. You'll find that on our website as well, with the demonstration plans work and anything else new happening at the company. So, John, I don't know if that gives us enough time. I think we're still good. So I'll kind of pass over to you if there's any questions. I'll always go back to some slides.
Yeah, Sarko, thank you for that. That was great. Thomas, can you provide participants on instructions on how they can log any questions, and then I will get the conversation started?
Yes, of course, John. So everyone, if you wish to ask a question, please press *1 on your telephone. If you decide to withdraw your question, press *2.
Perfect. So I guess I just want to start in just with some clarifications on the business model. Am I right to think the idea here, as you ramp up commercial, is to do it in partnership with the actual battery manufacturers? So, like, in other words, are you thinking like JV structure, or which involves you putting in some capital into the equipment, or is it more a licensing model? Just a little bit of talk about the business model would be helpful. Thanks.
Yeah. So I mean, we've been in both discussions really, and I think one that I see a lot of potential for is like a co-financing of a commercial plant with a strategic partner. That's where we're able to bring in our patented technology, and the strategic partner is able to bring in a vast network of logistics, operating capabilities, location of the supply of these materials, and also the use of these materials. And the reason we go with this business model is, I think short-term companies are going to be looking to get rid of their waste. Right now, if you're a battery company or an EV company, your focus is to make batteries and your focus is to make EVs. You're producing waste, but that's maybe not as very high volumes right now, and it's not something maybe as big of a priority. But in the future, we see that those companies at the end of the day are going to be the gatekeepers of the material that goes into the recycling stream. So if they decide, major EV companies decide they're going to do it themselves, that's not going to go to an independent recycling facility. They're going to build it themselves, and they're going to manage their own material. And then we see that with legislation as well, pushing towards an extended producer responsibility, especially in Europe and Asia. That's what we want to focus on, making sure we have the best technology. So taking our time through this demonstration scale, not building big commercial facilities and planning for or forecasting for a certain tonnage of material that we would need to recycle. But we want to build more of a build for purpose. So understanding what potential strategic partners' needs are in terms of how much waste they expect to be producing, and build to a scale like that, and have more of a homogeneous feed in and then a known quality out that can be cycled directly back.
Got it. And then in terms of strategic partners to date, or customers to date, or when investors should think about sort of the timing of those type of announcements?
Yeah, when it comes to, we have made some announcements in terms of MOUs. We have Itovolt is one gigafactory in Europe that was announced, and talking about this model of having recycling integrated within the battery production. In other terms, there's a lot of third parties we talk to are under NDA, but I'd say the discussion is kind of spread out everywhere, where some are more in advanced discussions, some more early discussions, but the process of doing this is where a company will maybe send us a few samples of theirs of black mass or scrap material. We'll process that. We'll understand what spec of material they're looking for in terms of like their lithium spec or their precursor spec. We'll send that back to them as well for testing the physical characteristics of the battery. So I can't disclose names, but we've sent materials to Europe, Asia, and North America. So timing wise, I think everybody is a little different, but at this point, we have our head down and do the work, and just with good technology, we believe things will fall into place.
Yeah, it's interesting in your sort of model. It seems different than some other players. So that you have the, let's build the capacity first on the idea that volumes are going to come. Where yours seems more sort of bespoke. We'll build the capacity as the demand is there. Along that, I just would love your insight on what you're seeing in terms of supply chain constraints for your customers. There's obviously anyone who's trying to buy an EV in the United States will quickly realize that there's pretty long lag times. Is that what you're seeing on your end? Are you seeing production ramps starting to come back online? Just any thoughts about the pace of the takeoff here after what was a pretty delayed start, I think, for a lot of the battery manufacturers and EV manufacturers.
So if I understand the question, you're asking what we're seeing in terms of battery manufacturing capacity or scrap, or sorry, maybe.
Yeah. Sorry, it's a long-winded that question. What are you seeing in terms of battery actual production ramp in the United States?
Yeah, so I think there definitely, as we're also all probably reading, there is a lot of production delays in getting materials. We're seeing mines taking longer to get online as well, and what was originally planned is not really there. And then as well, when it comes to the recycling side of things and planning for that production, like you had mentioned, our model is different, where we're not forecasting for a certain production, because as we can see, that's changing. So you build a plant that's 10,000 tons, and then that's not coming. You've got a ghost plant until that ramps up, or now you're bidding higher for more material because there's not as much out there, or you have a certain preference to a different chemistry because that one has a highest cobalt or a nickel that you'd like to extract. So it kind of fits into our model where it's still really uncertain. So we want to build to what's needed, because things are changing. These projections are changing every day. I think I update this presentation quite often, and then still end up being wrong or very different projections as month by month. And it's still very unexpected. I don't think there's still come to a steady state where there is material. I mean, we can see from the prices, it's kind of yo-yoed. So that'd be some indication as well. And I believe a lot more stockpiling of materials now, expecting prices to go higher. So then that's also constraining supplies. So I hope that helped answer. I know I was a little long-winded answer, but
yeah, no, it absolutely did. I've already gotten some emailed questions, and I have a few more. But before I get to those, Thomas, can we check to see if there's questions on the line?
There is a question in the queue, and it's coming from William Griffin. Please go ahead. Your line is open.
Thanks very much. First one, you started to touch on this a bit, was on the impact of volatility in commodity prices for these recycled materials. Are you expecting to pass that volatility on, if you're co-locating a plant, passing that volatility on to your customers, or do you anticipate having some exposure to price changes, and how do you manage that?
Yeah, I guess I don't think it would pass on the volatility to them, but it would help manage it better, because right now, if we're operating as an independent recycling facility, and terms on buying these materials are based on kind of like a payable on the hot commodity, whether it's nickel and cobalt payables, or that's primarily the focus right now, and what some of these technologies can recover is the nickel and cobalt, and very little of lithium. So a lot of the pricing is based on there. And then if you're going off of trailing averages, and you look at nickel price before, then the black mass would have cost you more a few months ago than it does now, and that's constantly that exchange, because you're dealing independently. You're taking in materials, and then you're buying it for a certain content, and by the time you process the material and look at selling a nickel sulfate or cobalt sulfate, that value may have changed as well, right? And depending on how these payment terms are, there's a lot of volatility there. But integrating, I believe it's, for example, a battery manufacturer, if they have every intention to make more batteries, and they have waste material with these materials in there, and they can recycle that. That's you have like a theoretical change in that value, but at the end of the day, they still need a certain tonnage of lithium. They need a certain tonnage of cobalt and nickel, and if they can get it from their own supply of waste, it's I guess a little working on the volatility together, but I think that's just all theoretical, because at the end of the day, they're going to need the materials.
Sure, thanks. And another one here on how you're seeing the cost of recovered or recycled materials today relative to the cost of mining virgin material, and where do you see, as you start to scale and commercialize some plants, where are the opportunities in this process to take some costs out, or is that even necessary?
Yeah, you know what? There's obviously a lot of cost savings when we look at, depending on, when we talk about primary extraction like mining, I guess it depends. Where are you mining the material, and where's that material going, and how's it being mined? It'll change. Even if you're mining a ton of nickel in two different locations, those parameters can be different. But there's still a lot of opportunity to maximize on the savings in recycling, where transportation is one of those big ones. Transporting batteries, if they consider it as a hazardous waste, there's certain requirements for that as well. So being as close as possible to this waste stream is the savings that we see there, and that's also another benefit to an integrated model. And then as well, kind of where the chemical reagents you're using. I showed the environmental benefit, but I believe there's also a cost benefit there, and I don't put those numbers. I just don't think there's as reliable public data out there in terms of how the cost per ton of some of these plants are operating. But just looking at the chemical consumption and that's involved, I see a big discrepancy there and variance between costs of recycling processes. So there's an opportunity there. But yeah, no, I think from an environmental and cost standpoint, compared to primary extraction, there's savings, definite savings, and even further opportunity to improve on that. As I showed, not all processes are the same.
Great. And last one for me. Do you see, I guess, is permitting of a co-located plant with a customer easier than permitting maybe a standalone, more centralized plant, which I know some of your peers are pursuing? Does that provide you with an advantage there?
So we haven't gone through a permitting process or commercial development yet. So it's under our belief and what we see that would simplify the process, being in a current operating area that's dealing with the similar materials, similar class of materials, even some of the same chemicals. So that I believe is an advantage versus going through the logistics of permitting and handling these materials and understanding kind of everything that needs to be done versus already an industrial zone or even an area of a factory where this has already kind of been hashed out. So yes, I believe so, but we haven't gone through the permitting process yet ourselves.
Great. Appreciate the color. I'll turn it back over to John.
Thanks for questions.
Thanks, Thomas. Anyone else on the line?
Yes, there's one more question. It's coming from Lance Marr. Please go ahead. Your line is open.
Yeah, thanks, guys. I guess maybe to follow up on one of those questions there around cost, you clarified that you haven't given operating cost savings ballpark, but you also mentioned that there's capital cost relative advantage versus other hydrometallurgical processes. Can you give us any sort of ballpark estimate as to, the cost savings on a comparable sized plant?
So I guess where I was getting at when we talked about the competing technologies and their high capital costs is when we're looking at the model of like an independent recycling facility, you're looking at building one large or maybe a few very large hydrometallurgical plants to achieve more of that economies of scale benefit of processing these materials, right? So you get a mixture of different feedstocks, and it's all going into one central location, where really our first output. So this is talking thousands of tons, where we look at our first kind of potential commercial design being more in that 3 to 5 tons per day range, and so that's more suitable for individual applications, so it allows more of a consistent feed of material in. If we're dealing with one battery manufacturer, a specific chemistry, so we know what's coming in, and then they'll know what's coming out, and it's more of a direct relationship. I think that's a savings there as well, versus when we have one large facility and you're operating really, really big facilities, you're getting laptop batteries, you're getting cell phone batteries, you're getting EV batteries, and all different sorts of different chemistries, and then that requires a really mixed feed, and I think that has its complications as well in the processing of it. So I don't think there's like a comparable or comparable size, because I think from we would build more smaller but more strategically located facilities versus more one central one where material is sent to. We do have some in-house estimates on what that 3 to 5 tons can be, but again, this is information that'll get further refined as we go through demonstration plant work, and I think there's increasing costs and everything, so I try and avoid kind of quoting any numbers until we go through a more detailed engineering review. But we do have in-house estimates, and we find that there's a big advantage to our cost.
Okay, thanks. Understood. And if I could, one more is kind of a related question on the various inputs and outputs, but and maybe you addressed it with the plan here is to be much more strategic with individual producers. But could you talk a little bit more about the process and your ability to optimize the output of the precursor cathode materials? And do you have ultimate flexibility there to, whether the customer wants 811 or 622, 523, and are you able to achieve or optimize the process for LFP as well?
Yeah, so when it comes to, maybe for other listeners, maybe they'll understand, like your NMC 811 or 622, I guess the composition of the nickel, manganese, and cobalt that's within these batteries. An older generation would be more of like a 111, whereas like an equal composition of nickel, manganese, and cobalt. And now we're transitioning more into these modern next generation batteries where it's a lot more nickel heavy with less cobalt and manganese. And with that, that's important because the first batteries that will be recycled are the older generation. And then if we're going back into precursor, we don't want to go back to something that's out of date. So in our testing, we actually have taken like black mass that came from like a mix of like 532 and 622 NMC. And what we've done, once we leach into solution, we're able to actually adjust that solution before we co-precipitate out. So we'll add in, additional nickel to bump up that content of nickel to more of an 811 composition, and then that's what would be synthesized or co-precipitated out as an 811 and to that. So we have that flexibility there. And then, some of these advantages in how we're able to achieve this, through our leaching process, which we have patented, and we do have publications out there. All this is shared on our website. So, we are very transparent, and you can really dive into the technical details through these sources. And then as well, when it comes to the regeneration of our process chemicals and the lithium production, this is where we see some major savings, environmental and cost. When it comes to LFP, so we have kind of, I wouldn't say, when it comes to recycling these NMC, NCA, like those chemistries, we've moved further along with those because we just see a higher value potential. When it came to LFP, from a value perspective, we didn't see a big opportunity, but we obviously now recognize that LFP is a growing market, and we are looking at potential opportunities there. But nothing at the current scale we are at now with the demonstration plant. So there's we have been putting thought into that, but I think the value driver for the LFP is not there at the moment.
Oh, okay. Thanks for the call. Appreciate it.
Yeah, thank you.
All right, great. And then, we've only got about 7 minutes left, so I'll sort of roll up. I think probably the most common emailed question, which was emailed in sort of various different formats. A lot of people are just asking if you could talk a little bit about the competitive landscape, that it seems like there's a lot of capital or like businesses looking to exploit this opportunity. Some specific names mentioned were Ascend Elements, Redwood, and RecycLiCo. So can you just talk a little bit about how you're seeing the competitive dynamic? Is this, there's enough room for everyone given the growth, or there's going to be some winners and losers? Just how you sort of think about how you fit in and how this evolves over time.
Yeah, I mean, it's see those companies, and we're all doing a very honorable thing, I think, and then it's a great mission to be after and to be competing in. But I think they're structured off of like different business model, which I was really emphasizing during the call of integrated versus independent. And I think when we look at what's going on with those companies, there's a lot of expansion right now in capacity, and I believe right now a lot is on the front end. What would be called the mechanical shredding of the batteries to produce the black mass. But I think when it comes to the hydrometallurgical processing capacity, I don't think that is yet developed at scale. I think there's a lot of front end work going on right now, the collection, the disassembly, shredding of batteries. But I don't believe that the hydrometallurgical side has caught up to scale. And I think it's using a lot of the competing, like the conventional methods of, like I've shown in the slides, like solvent extraction and producing the individual metal salts. So you'll see a lot of pictures of nickel sulfate and cobalt sulfate, and remind people that this is also now needs further refining into precursor materials. So we are producing different products. When I see we're producing a higher value product in fewer amount of steps. And then as well, so going off of that model, I think the biggest thing is those companies are more competing amongst themselves right now in terms of who's going to get the supply contract. Whereas I think we look to come through the back door and integrate our technology to a point where there is no RFP for the supply of the waste materials. It's being done in-house using Recyclical technology. So, I don't think our company is at the scale or has the resources to be bidding on waste batteries and to be processing those. But we do have a patented technology, a very advanced technology, and I think that will be recognized in the long term. But I think short term right now, companies are looking to get rid of their waste, and there's a business model for that as well. And I think there's room for everybody. There's going to be some companies who don't have the capacity to have an integrated process because they just don't produce enough waste, and they'll send it off to somebody else. and there's some like the EV companies and the battery companies who are going to be producing thousands of tons, and I think it's going to be in their best interest to integrate. So, I'm always following along and wish all those companies the best success. And I think we're going two different approaches, and are going to offer, try and offer best solutions. So, yeah.
Got it. Perfect. And with that, we're getting close to the top of the hour, so I'm going to start to wrap. I would just remind everyone, I think this call could go on for another hour. It's very interesting, but these calls are meant to, a lot of times, to be an introduction to some of the companies. So I do believe that Darko provided some contact information there in the last slide of how you can learn more about American Manganese, which is operating as RecycLiCo battery. So with that, Darko, thank you so much for being here. I really appreciate it. I am going to give you the final word here in a moment, but I just want to thank Thomas, the operator, for helping us out, as well as all the participants who asked questions live on the call or emailed them. So they really appreciate your help and really appreciate your interest and support of the UBS Energy Transition Call Series. Darko, the final word is yours. Thank you so much for being here.
Yeah, thank you. I guess just the way I started, thinking for those looking at the leading edge and next generation of technologies will be in focus when we look at sustainability, when we look at EVs, metals, circular economy. Recycling really covers all of those points. And I know the markets are going through a very tough time now, but this is future looking, and looking towards a better future. And I think these are kind of technologies that we're going to need. So I just want to thank everybody for listening, and please feel free to contact me. We have all of our information on our website, and I'm readily available. So thank you so much.
Thank you, everyone. That concludes your conference call for today. You may now disconnect. Thank you for joining, and enjoy the rest of your day.